JB, so thank you for answering this in a so busy schedule. I know we've
Thanks.
done this before, but still, like, can you introduce yourself for the audience?
Okay, yes, so thank you. I'm a professor at the university in Saint-Étienne in France. That's the beautiful lab and place you see behind me. And I'm a researcher in biomechanics and sports performance. I'm the director of the sports science department. And I am also a consultant and advisor for coaches and athletes. And I was in the past a coach and an athlete myself. That's my current job.
Cool. So, uh, I know like recently launched like really good paper recently. So what like can you give us like some clue or some like thoughts about like what gave you the thoughts of like doing the paper about like mechanical and metabolic power for like team sport athlete and like 100-meter sprints.
Yeah, so that's a two-part piece by Professor Di Prampero from Italy and Christian Osniak and a couple of colleagues. So I'm just a collaborator on that. And the idea was to describe the movement and the performance in linear sprinting, track and field, 100-meter, and in team sports in terms of not only the velocity of running or the speed of running, but also mixing two informations, the speed of running and the acceleration. Because if you run at the same speed, like, I don't know, 4 meters per second, then you produce a given amount of speed that's the same. But if at 4 meters per second, you also produce a little acceleration, like 1 meter per second square, or a big acceleration, like 3 meters per second square, the speed is the same, but the mechanical requirements of this effort, and so the energetic requirements of this effort are not the same at all. So it means that by mixing speed and acceleration, and if you prefer speed or force output, because you know from the laws of Newton that if you accelerate more, it's because you are producing more force onto the ground, we have an idea, an equivalent of the change in mechanical energy. That is, over time, an equivalent of power. So the idea is to say, if you want to monitor and understand performance, you not only have to assess and monitor running speed, but you also have to integrate and add acceleration or force to that speed. And this, to me, changes the view of, for example, team sport training, because if you do a team sport session and you look at the average speed, or you look at the speed during a given exercise, you might have two similar speeds, but two very different sessions. Because if for a similar speed, you did many accelerations and so many decelerations, the intensity of the exercise of the session is incredibly different, yet the speed metric is the same. So that's the main point in these two papers. And I think the team sport paper is even more interesting because it says, wow, if you only have the speed or the distance metric, you're missing exactly the point.
So, in order to like monitor like let's say team sport athlete, like the speed you mentioned or the like the acceleration you mentioned, does like do you think like GPS is a good tool for that?
I would say it's the number one tool because you can do this in a much more, let's say, laboratory based way by using 3D motion capture, but this is almost impossible. You can do it in a pretty accurate way by using what we call local positioning system, or LPS. But today the GPS systems are the most popular and the most directly accessible tools to do that. But it means that you need to have very accurate GPS systems, and you need to have very good measurement conditions, because otherwise the metrics will be wrong, but not because of the model, because of the devices you use.
Nice, nice. So, like, did anyone did any coaches like give feedback about like the 100-meter sprinter, or like the team athlete, like after that, how would they change how they train their athlete?
I don't know yet, because that research is very recent, and but in some teams they are already monitoring the metabolic power, and so they have a better idea of the output of the session, of the load that is associated with movements, and I think it brings a more accurate information. Then what people do with the information, I don't know, and but I know some clubs who are working with this approach to assess the players.
Nice, nice, nice. So the other paper I was interested is also you just recently like launched, and really enjoy is like the title is like exploring the role of biomechanic in hamstring strain injuries. So um how important, I know like this is kind of a stupid question, but how important is sprinting mechanic in like preventing sprinters to get a hamstring injury?
So that's a very interesting question, because except for overstretching types of injuries, high speed running types of hamstring injuries are very, very frequent in sports like football and track and field or rugby. And so the idea is to say we want to be closer to the main injury mechanism, because when you run at high velocity, you have a high mechanical strain in the muscles, which means both at the same time a high length of this muscle group. When you have both during the swing phase of sprinting, the hip flexion and the eccentric deceleration of the knee extension, at that moment, your muscles face a lot of strain because they have a high length and because there is a lot of tension, because they have a high activity. And so these two components of the mechanical strain make the muscles basically fail to face that strain. And so because it happens during sprinting, we think that it's a good way to prepare for this mechanical strain to do the actual movement. And so there is a debate here, because if you hear that, you might say, look, if this is the mechanics of injuries, then we don't want to do that type of movement, because we don't want to expose the players to that risk of injury. And we say the opposite, because the problem is that if you don't expose the players to that mechanical strain, first, there is no way you can do it with another type of exercises. There is no way you can reach the length, the speed, and the activity of the hamstring muscles than by doing high-speed sprinting and high-speed running and sprinting. And the second thing is, if you don't sprint and you avoid sprinting in training, you will never avoid it during the games. And so because it's a component of the game, we think that a normal preparation should also include that in preparation. But of course, it should be well dosed, it should be progressive, and it should be well managed. But we think that's the reason. And the second point is that in addition to this exposure, we also need to consider how the mechanics of sprinting influence the strain in the muscles. And this is what we've published recently. We have listed all the components of the running motion, how you run, and how they influence the mechanical strain in the muscles. Because if you and I, we both run at the same 90% of our maximum speed, maybe my running pattern, my trunk position, my pelvis position, and so on, will be different from your pattern. And so it means we run at the same speed, but we absolutely don't have the same amount of strain in the muscles. And we think that we need to focus on both the macroscopic exposure and the microscopic behavior of the muscles. Because for some players, if they sprint too much and they have a lot of strain associated with their running pattern, then yes, that might be counterproductive. You see, so
Yeah.
it's not that simple.
Yeah, I love it. I love it. It's like uh it's like I have a player I train and he basically has the fastest speed in our team, and but the like pelvic control is bad. The like he couldn't get to like front side mechanics, so he's always complaining about like tightness. He's always complaining about like hamstring strain. But the other players never had the problem.
Okay.
Yeah.
Yeah. But
So that
he has the same volume and everything is similar. He has the same, I guess, muscle exercising and preventive programming and so on.
yeah, yeah. So uh that leads me to the next question about like sprinting, top speed sprinting is uh like you mentioned, it causes a lot of like um strain in the hamstring. So we yeah, we probably can do like high speed running is probably the most like injury prevention training for hamstring injury. But
Mhm.
besides of like hamstring, besides of like max velocity, um, do you think that like fast eccentric or like isometric for the hamstring also is gonna help? Or like which one is like most closer to what we're doing when it's high speed?
Yes, to me, the big stone, the big rock should be high speed running, at least 90% of maximum speed. Because again, 25 kilometers per hour, if your maximum speed is 35, that's nothing. That is not sprinting. Mechanically speaking, that is not sprinting. Then, in terms of additional work, I would say that yes, there should be some very dynamic, eccentric work, very explosive isometric work at different lengths. And I think that we should explore the entire length force relationship, different modes of contraction, because what athletes need is adaptability. And so if you always focus on one length, one type of exercise, only a proximal or a distal stimulus, and one day during the game you have a stimulus that is a bit different, maybe you will not be adapted. So the idea is to cover as many contraction regime, lengths, loads, type of exercises as possible. So I am not a big fan of what is the best exercise. I'm a big fan of you need to strengthen your muscles so they increase their capacity, but you also need to strengthen their adaptability to many types of lengths, exercises, and so on. So yes, definitely that's an important thing. But to me, it comes as a number one, as a number two option after the number one, that is the specific type of strain. Because the problem is that in terms of intensity, timing, mechanical strain, EMG activity, there's many studies showing that you cannot match top speed sprinting and high speed sprinting. So you have to go there.
Cool. So the other question after this is like, different teams or like basically teams or athletes have different like sprinting mechanic than a true sprinter. So
Yeah.
how close or like how deep do we want our athlete to like um to master or like to study to train those like or to be more like a sprinter?
Yeah, that's a good question. I think being more like a sprinter should not be the discussion, because you don't want them to be more like a sprinter. The discussion should be run like a team sport athletes with less mechanical strain. To me, this is a bit different. You don't want them to run like sprinters. You want them to run like team sport athletes, but with less mechanical strain. So it doesn't mean that they will become, the Usain Bolt on the pitch. This doesn't make sense. We know they are not. We know they have other things to do than running on the pitch, So, but you want them, for some of them, and this is very individualized, you want them to run with a bit less strain, a mechanical strain in the muscle. And to do that, you need to adopt some running kinematics that are, for most of them, a bit closer to sprinters. Yes, but you don't want them to become sprinters.
So instead of focusing on like the shape, probably focusing on landing correctly on max velocity, right?
Yeah, the idea is we've defined, I think, something like 5 or 6 big items to focus on. This is a great work done by a physiotherapist named Chris Brahma. And the idea is to have the trunk, flexion and rotation, the pelvis position, and if it's tilted too much forward, then you have a stretch and so a strain in the hamstrings. Then we talk about the separation of the thighs when you touch down, because what happens when you touch down? When you touch down, you are in the very high strain zone of the cycle, and there is a huge amount of ground reaction force that's going to hit and go through your system. 3 times, 4 times body weight. So if the position of the limbs, because they are heavy and there is a lot of lever arms and torque around the hip, if the positions of the limb is with a big trailing leg and a big overstride, then you will have more tension. And the last thing that we check is the position of the foot compared to the center of mass at touchdown, because we think that if you are overstriding, which means if your foot is way ahead of your center of mass when touching the ground, there's a risk that you have more extension of the knee and flexion of the hip, and flexion of the hip, extension of the knee means more strain in the hamstrings. So we are now working on an index, like a score, to score all that and to think about that. And the funny thing is that when I assess my students or some players in slow motion video, we see that there are many different patterns. Some people have a good straight trunk position, some others have less, and there is no typical team sport player profile. So we need to individualize the approach, definitely.
Nice. I love that. I love this project, man. So after the new paper, I want to like go back to like what we kind of discussed before is about like force velocity profiling for like sprinters. I happened to like get a chance to work on like 1080 sprints, which is really cool. So and I know we discussed this before, but like can you walk me through like how exactly do I build the force velocity profile for a single individual athlete, especially for sprinters?
So if you want to know the force output that you are producing on the ground to accelerate as a function of the running velocity, this is exactly what you want when you are building the force velocity profile. You have to measure the force at every step, and you have to measure the velocity of running at every step. So you have one way to do it, it's to use force plate systems or instrumented treadmills. But the problem is that you will only find them in a couple of laboratories in the world. The other way to do it is to measure the running velocity, because when you know the running velocity, so the speed, the forward speed of movement, you can calculate the forward acceleration, and then with the laws of Newton, you can estimate the force output that in that direction. So basically, this is a model that we have developed and validated against force plates twice in 2 studies. The idea is if you can have the velocity input or the position input, you can calculate the acceleration and the force output. And so if you have that, then you can build that force sprint mechanical force velocity profile in the athletes. And so you can use some devices and some Excel spreadsheets that we have published to use that model, or you can use some machines where there is an option, like the 1080 sprint machine. There is an option in the software to calculate everything for you based on the laws of Newton. So that's pretty simple mechanical variables.
Yeah. So in a 1080 sprint, we can like load, or like we can do the resistance sprinting like pretty heavy. So I know it depends on each athlete's like force velocity profiling, but like do you think like loading too heavy for these sprinters is probably gonna like change their mechanic and cause injury?
So definitely, if you use resistance, just like you use resistance at the gym, when you do an exercise, you use resistance. You will induce a change in the movement for sure. So as soon as we add a significant amount of resistance to a movement, we basically slow it down, we change the motor pattern, but the objective is to overload the movement, so to develop force, because there is one law in physiology, is that if you want to increase the level of force in a muscle system, at some point, you will have to increase the level of mechanical load in that system. And so resisted sprinting is a way to induce a mechanical load specific to the sprint movement to increase the force output in sprinting. And to answer the question of injuries, well, I would say yes, you definitely have a risk of injuries when you do overload in any type of exercise, including sprinting, if you don't respect the training rules of familiarization, technique, progressivity, and so on. So to me, there is the same amount of risk in doing resisted sprinting than in doing any type of training. If you start doing some full squats tomorrow, you never did, and you do many full squats per day, per week with heavy loads, and you don't go progressively, you will get injured. So it's exactly the same for sprint resistances.
Nice. So for resistance sprinting and for like sprinters, usually how before, like we discussed it before, like they need to be the athlete need to be like good enough to use force velocity profiling. They need to like you mentioned, they need to like uh how to say this, anyway, in order to like progress our athlete to prepare to do the force velocity profiling, how would you like, what are some checkpoints before using it?
Very interesting. You mean resisted sprinting, huh?
Yeah, sorry.
Yeah. So to me, the checkpoints are first being used to this type of overload. So you can start with, if they never did it, you can start with very low loads. You can even start with resisted, elastic bands resistances. And then you go progressively to very light loads, to medium loads, and so on. That's the first point. The second point is that they also need to have a good control of their trunk and pelvis motion in running, and also a good power in the plantar flexors, because that's the main muscles that are going to be stimulated, the plantar flexors. So you can start with a bit of heavier plyometrics, a bit of isometric resistance. To me, isometric resistance is a good way to introduce the overload of resisted sprinting. And to me, the best adaptation is to do the actual stimulus, but by respecting the rules of progressivity of the overload. So typically, you can start with 2 sprints twice per week with very little resistance. That's going to be totally okay. Then the next week, you do 2 times 2 sprints with a higher resistance. Then you try 3 times and so on. You respect the basic rules of overload and progressivity, and it should be fine. I work sometimes with young people, And of course, after the first session, they have a bit of pain, in the muscles, but then they adapt and they push very well, exactly as for strength training. It's a type of sprint specific strength training.
I know previously we discussed it. You kind of mentioned it's kind of like velocity-based training in sprinting, right?
Yeah, so the idea here is to say, okay, when you sprint, you can move at velocities that range from 0 to your maximum speed. This is a spectrum. And if you use resistances, you can use resistances to overload at the specific running velocity of the entire spectrum. So if you use almost zero load, you will be at very high speed. If you use very heavy loads, you will be at very low speeds. And so it means that you can target any part of the spectrum that you think it's interesting to stimulate. And because it's exactly the same as at the gym, you have velocity-based training at the gym, because what you want to monitor is not the load, it's the velocity of the bar. Then this is velocity-based training adapted to sprinting.
Cool. The next one, it's kind of simple, but I'm still gonna ask it anyway. So there's like force velocity curve. So why, since there already is a force velocity curve, why do we need to profile our athlete in a like load velocity relationship?
Yeah, that's interesting, because the idea is if you assess your athletes, basically what you measure is, in a given movement, one, performance, time, speed, Second, you can do some physical capabilities tests, like a strength test and so on. And then what are you going to do? You're going to want to know more about the physical capabilities of the athletes, because in different loads, in different levels of constraints, we have different outputs. So for example, if you and I, we do a squat jump, we will maybe not have the same performance. But if you and I jump with 50% of body mass on our shoulders, we might have a difference, and maybe in the opposite direction. So the idea of doing the entire force velocity profile is to know the capability of the athletes against different levels of loads. And that's the only way you can know it, because if I have only your jump performance in a squat jump, I know only 1 point in your entire spectrum. And so this 1 point doesn't allow me to know if you're better or not against the high resistance, if you're better or not against the low resistance. So that's the only way to know the exact thing. It's exactly like for endurance. If I want to know your endurance, I will test you on a 5-minute test. But if I don't do a 2-minute test or a 1-minute test or a 2 hours test, I will only know one part. I will only know one part of your profile capability. So the idea is to know more about your athletes.
Nice. So, since we're talking about like load velocity profiling and like resistance sprinting, do you think that like let's say football player, American football player, or like soccer player using resistance sprinting during the season is gonna help like help improve like their performance and like preventing and hamstring injury?
I don't know, but I think it might help their performance, because you are targeting an overload of their sprint capability. And all the team sport players that we have followed, or the teams that we work with, who really addressed and added that resisted sprint training to their training, saw a good effect on performance. Now, in terms of prevention, I only have some anecdotal reports, but in 1 or 2 football clubs where they started doing resisted sprinting and do it well, in addition to a good sprint mechanics work, they had some pretty good results in terms of hamstring injuries. So Of course, there is no randomized controlled trials yet because it would be pretty complex to do. But first, it makes sense from a theoretical perspective, to overload your system to the specific task of sprinting. And second, we have some teams and very high level teams using it and with pretty good results.
Nice. So last question before I let you go. So in order to like it's more about like 100-meter sprinter. How would you train their like energy system for like for I know there's like acceleration phase, there's like max velocity, there's like speed endurance. So how would you train their like tempo run or like yeah, for speed endurance and like recovery?
Can you repeat that for speed endurance and tempo
And
runs?
yeah, for and recovery.
I'm not a big specialist of that in terms of research, but in terms of practice, I think we can really benefit from using repeated tempo runs, because the big advantage is that they are not very difficult in terms of strain, mechanical strain, and they might help putting the athletes in a fatigue situation. And I think it's very important to sometimes work in fatigue conditions. So this is why. And in terms of recovery, you mean to use them to recover?
Yeah.
Yeah, I'm not sure it's going to be. I think it's going to be a taxing exercise. So I'm not sure it's going to be a very good recovery type of stimulus.
Nice. So that's kind of like the question I have for you today. So if there's like coaches are interested in what we're talking about today, where can they reach out to you?
Yeah, sure. The best way is to log onto my website, jbmorin.net, and there is a form. There is an online form. So you write a message there, and from that message, I will receive an email. So as you said at the beginning, I'm pretty busy now with teaching and research, but I tend to answer to all the emails there. So that's the best way to reach me.
Nice. Thank you.